Okay, so I'm going to be talking about CSS animation. Definitely look better with the lights off, right? Yeah, so the talk's called Beyond Transitions. My name is Stephen Roberts. I've worked in this industry for around about 10 years now. I started at a company called 360 Fusion, where I was building virtual tours and websites, mainly brochure websites. I then went to work for a better brand agency over in Middlesbrough, where I built yet more brochure websites in WordPress. And then I went to Assembler, where I started as a creative developer and started working on SaaS products instead of brochure websites, and quickly became head of UX there. But enough about me and how I used to think I was cool. So why bother to animate at all? Animation can be used in a number of different ways, but animation can be used to delight your users. Simple animations like the one shown on screen can create a memorable experience. You can keep your users coming back again just by providing them with something to remember. Use animation to inform. So this is to use animation to inform your users that something has changed. So be it clicking an accordion or a button or anything like that. Animation can really cement the interaction with the user. It can really help them contextualize what's happened, especially on mobile and things like that. If you tend to hit the button or something with your thumb or a fat finger, you can accidentally sort of end up somewhere you didn't know how you got there. Whereas animation can kind of help you show the user where they've come from and where they're going. And then finally, use animation to confirm. So this is whenever you're submitting data, loading pages, anything like that. Using a simple animation like the one that you can see on the screen can keep your user from clicking around or refreshing the page or anything like that, and keep them engaged for at least a few more seconds, which is usually long enough to at least submit some data or load a page or anything like that. Okay, so why CSS over JavaScript or Smile or any of the other animation properties or libraries? Well, CSS is performant, simple, and powerful. The simple and powerful bit we'll come on to when we get into some examples, but performant, you can see there, has an asterisk. That's because performant animation is really only able to be done on 3 properties, and they are transform, opacity, and filter. It might seem quite limiting, but those are actually quite broad features that we can do quite a lot with. It's also worth noting that in the future, this won't be a problem. Firefox are working on their quantum browser, which means that a lot of these properties you'll be able to animate without causing any problems with jank or stuttering or anything like that. So the talk's entitled Beyond Transitions. So why do we need to go beyond transitions? What's wrong with transitions? Well, absolutely nothing. Transitions are great, providing you can get out of it what you need. So take this example. We have a nice button, and then we're saying transition the stroke. So as we hover over, the stroke changes color. And then this one, we've changed one word, and magically it changes shape. So it's just one word. Okay, so not quite. We still need to tell it what and when to animate. So here we're saying the menu icon that we were just looking at there, it's made up of 4 lines. So instead of it, you can only see 3, but there's 4. So lines 1 is at the top, lines 2 and 3 are in the middle, and then 4 at the bottom. And then upon hover, we're saying take lines 1 and 4, fade them out, and then take lines 2 and 3 and rotate them in opposite directions to create the X shape. Pretty simple. Okay, so one more example using just transitions. So these are some cards that you'd probably find on most websites, and they have a corner cut out where it's showing a category color, and then when we hover over, we're revealing the category name. It's pretty simple as well, but again, how did I do that one? So this one's made up with the before and after pseudo elements on the box itself. So one of them does the border shape, which is the CSS triangle, and then the other is the name itself. And then upon interaction, all I'm saying is transition the border width to expand, and then transition the before, which is the name, to bring it into view. Pretty cool, pretty simple. So transitions are awesome. You can do a lot with them, but they're also quite limited. You can only animate from one property to another. You can go from, let's say, 0 to 100 or 0 to 50, but you couldn't go 50 to 25 to 75 to 0. You can't do anything more than just that one sort of jump in values. So that's where CSS keyframes come in. CSS keyframes, it seems strange, it's 2019 and I'm standing up here talking about CSS keyframes. This is something that's been around for 5 years at least, and that's in production. So why am I standing here talking about it? Well, it kind of just feels like no one's really using it, or at least not using it to its full potential. Since Apple kind of killed Flash off, it feels that animation's taken a bit of a backseat in the web, and it just doesn't seem that many people want to use it or don't really understand how to anymore. Whereas at least Flash gave us a nice timeline and things to play with. It's just not quite as simple to jump in and get started anymore. So hopefully I can demystify some of that for you and inspire you to go away and have a play with some keyframes and see what you can come up with. So this is our first example using keyframes. This is a nice simple scrolling mouse. You've probably seen something very similar on many websites, possibly some that I've made. Usually sits at the bottom of a hero area or something like that. It tells you, indicates to the user that they need to scroll down. So how does this work? So it's made with an SVG. The SVG is made up of two simple shapes. It's a rectangle and a circle. The rectangle around the outside has some rounded corners, but for the most part, it's simply a rectangle and a circle. So to begin with, we need to style those elements in our SVG. So I'm saying the outline has no fill, but has a stroke width and color. And the scrolling wheel itself, the circle in the middle, has a fill color and an opacity. The opacity we'll come on to in a moment. So there you can see basic styles applied. We've gone from the shape to the styled element. So then we can start creating our animation, start having a play, see what we can do. So here's our keyframes. We're only really animating two values. That's transform, sorry, two properties. That's transform and opacity, and then two values within the transform. So here I'm saying the translate y is 0, so it's just not going to move, and then scale y is 1. And then when we get to the end of our animation, the translate y will be 36. So we're moving the circle along the y-axis down over, and then we're actually stretching out the shape as well along the y-axis. So we're elongating the scroll itself and then fading it out as it performs that animation. So when we apply that animation to our circle, giving it a name, duration, and iteration count, you can see it didn't work. Huh. So why didn't it work? Does anyone have any ideas? Cool. So the transform origin was missing. We weren't telling it where to animate from. So that was what we were missing. So once we apply that transform origin, we can see that the animation's now doing roughly what we thought it would. But it's still not quite what we wanted. It's still not the original one, which is on the right. On the left is what we have now. On the right is what we're aiming for. So we can achieve that by applying one more property. Again, do I dare ask, does anyone know what property that is? Okay, so that's the animation timing function. So the animation timing function allows us to apply a few key values, such as linear or ease or properties like that, but there's also a couple of functions that are programmable. So we've got cubic Bezier here, which is basically saying it's a custom timing function. There's a bunch of GUIs and things on online that you can find that will show you how to adjust the graph to see what's happening, so you don't need to memorize these numbers or what they do or anything like that. But once we apply that custom timing function, we've now got the animation we were aiming for. So it sort of has that playfulness about it where it kind of jumps up a little before it drops down, and then the fade works a lot nicer, and you kind of miss the fact that it's stretching, but it's still there, so you see it a bit. So it's just got a little bit more playfulness to it and looks a bit nicer than our original one. So in less than 5 minutes there, we've gone from a completely unstyled SVG to a finished animation. So it's not too difficult to do. Like I said, it just seems like no one's really doing it. But yeah, not bad. You've probably seen something very similar before. Let's see if I can really impress you this time. So this animation I'm going to show you is completely made of CSS and SVG. So how does this work? So the key here is the animation timing function again. So like we said before, we had cubic Bezier as a programmable function. We've also got this function called steps, which allows us to tell it how many times to step through the animation. Instead of being fluid, it will do it in steps. So you're just telling it how many. But we'll come back to that in a moment. So first off, for the birds, I needed to create the actual image itself. So you draw your first pose, then your remaining poses. In my case, I did 10 because I had about 7 other animations I needed to do that day. But the more frames that you have, the smoother your animation will be. In my case, 10 worked just fine. So once I created all of the different frames, I split them into equally sized boxes and then exported the file. The image at the top is just to show you the boxes that I created and put them in. I didn't actually export it with the boxes. The image below is the one that I actually exported. Okay, so once we've actually exported the image, we need to move on and try and make it fly. So we need to jump over to our HTML, create our first HTML element with the class name of bird. And then I'm saying here the background image is that image we've just created. The background size is auto 100, so it will actually stick to the height and not the width. And then I'm saying will change is the background position. So will change is like a fairly newish way of optimizing performance. It kind of works the same as Translate Z or Translate 3D, if any of you have any used that. And then the only other two values here are the width and the height. Now this is where it gets a little bit muddy, a little bit more complicated. The height was chosen at random, so I just decided 125 looked good, that's fine. And then in order to get the width of a single cell, I used a ratio calculator. So once I opened up the ratio calculator, I plugged in the original size of my SVG view box, and then the height, and then that gave me the remaining width. Once I had my width, I divided that by the number of cells, and that gives me the width of one single cell. It sounds quite complicated, but really it's not. You're just doing some very quick maths just to work out how wide one cell should be. And then when you've done that and you show that on the screen, you can see the first cell of your animation. It's not actually doing anything, but it's there. So then the next step is to create our animation, set up the keyframes themselves. So I've created my animation, named it fly cycle, and then the animation itself here is really simple. It's just one property, changing the background position, and all we're doing is moving it from right to left. It's the bit next that we talked about where we were with the timing function and steps. That's where the clever bit comes in. So by telling it how wide the image is and how many steps there are, it will jump through that image that many times over the duration of the animation. So once we've actually applied the animation, I needed to set duration and delay. The reason that I've not put that on the other class is that I have variations of this. So there's actually 4 different birds that all fly at different times. But here I'm saying the duration for the first one is 1 second, and the duration is minus 0.5 seconds. And setting a negative delay means that the animation will already be running when you hit the page. So when we apply that, you can see the birds flying on the spot. So if we go back to our code and create our other variations, so variation 2, 3, and 4, set different durations and delays. You can set them randomly, you can set them however you want. When you actually see them all in a line, it's not linear. It's not like any of them are repeating the same animation. They all look very different and they never sort of sync up or anything like that, but they're all using the same image and they're all using the same keyframes. It's just different durations and delays. So once we have that, we now need to move them across the screen. So it's no good them flying on the spot unless you want to move the background. You could do that, but in our case, we want to move the birds across the screen. So we start with each of them and wrap them in their own container, position that container off the screen. So position absolute, top 10%, left minus 10, so we're way off the left-hand side of the screen. And then we can start to create our animation. So again, we're using the transform property here, and I'm animating 3 values within it. So there's translate Y, which will be used to move the bird up and down along the Y-axis, translate X, which will move it from left to right, and then scale, which will actually move it, well, not move it, but actually make it bigger and smaller as the animation goes on. Now, by applying the scale as we fly across the screen, we can give the illusion of depth. So if we make the bird get bigger, it feels like it's flying closer to the screen, and if we make it smaller, it feels like it's flying away. So that's at 0%, we've positioned it off the screen. By 10% of the way through the animation, the translate Y value is at 2, so we've moved down a bit, we've moved across a bit, and we've got a bit bigger. Now, there's a whole bunch of steps here all the way up until we reach this one, which is 60% of the way through. And at this point, we want it to have finished. So translate Y is 0, that doesn't really matter because we've reached the other side. And translate X is 110, so we're right off the other side of the screen. And then our scale is 0.6. Now, the reason that I've finished at 60% and not 100 and repeated those values at 100 is because when I run this animation in an infinite loop, I want there to be a delay between them playing again. And there's no way to do that in CSS. So you can set animation delay, but that won't work with infinite. It will delay the first time, but then it will run infinitely. So the only way to do that is to put a gap in your keyframes. So then once we've created that flying animation, we need to apply it. So same as before, give the animation name, timing function, iteration count, and then set a duration and delay again. In this case, it's going to take us 15 seconds to fly from one side of the screen to the other, and there's going to be no delay on the first bird. So once we've so once we've done that, we go back and create the variations again. Whereas before I was choosing random delays and random durations, at this point the delays are all staggered in a linear fashion, and that means that the birds can actually follow each other across the screen as opposed to just sort of like randomly appearing. And by setting the delays and durations to be slightly different and it being on an infinite loop, when they come back around again, they won't be in the exact same positions. They'll start to overlap each other. They'll start to do some quite interesting fly patterns. So you can see two of them are quite close together, and the next time round it'll be different still. So that was pretty cool. You can do quite a lot with it as well. I mean, it's not just limited to birds. You can do this with a walk cycle, or you can do it with like a car or anything like that, where the wheels are turning. Anything that really just needs to have that sort of stepped animation. So the next one I'd like to talk about is this favorite animation. This is used on the assembler website. So when you click the heart, it sort of shrinks down, expands, and then gets the circles appear around the outside. So how does this work? So same as before, step one is usually creating the image itself. So we start with the heart shape, so we create our SVG, and then we create our path, give it an ID, and then we go and write our path. Nice and easy, M12.745.1667. Okay, yeah. Right, so yeah, you don't have to write them by hand, you can, and if you've got the skill to do that, all power to you. But you can just use an editor online like Sketch, or you can find an SVG of a heart shape or anything like that. But once you have that shape, you need to export it. So once I've exported that, I've applied the view box and then give it just another inline style to say overflow visible. That's because the circles as we animate are actually going to go outside of the original size of the SVG. So once we've exported the SVG, we need to actually create the circles. So the circles themselves aren't overly complicated, so we can do that bit by hand. So I'm creating a group, translating that group to be in the center of the SVG, and then creating 8 circles within it. So once we've done that, we can move on to the animation. So the animation itself, again, starts with its initial styling. So the heart itself has a stroke, color and width, a fill color, which is the same as the background, and then a transform origin point. So there's our initial style. So from here, we need to actually create the animation. So the animation is made up of 2 or 3 properties. It's the transform property, which we're going to use to scale the heart up and down. And then we're going to animate the stroke and the fill colors as well. So if we start with the colors, what I've done here is I've set it 33% of the way through the animation, so a third of the way through. The fill color is still going to be the same, but the stroke will have changed to be a different color. And then by the end, both of them will have changed to be that color. And then when we run that, we can see the outline goes first and then the fill. So the reason that we've chose those numbers at 33, 66, and then the end, so basically thirds, means that we can sprinkle in the transforms around the same points to create what looks to be like a choreographed animation. So at 33%, when we just changed the stroke color and not the background, at that point, we're going to scale the heart shape down to 80% of its original size. And then by 2/3 of the way through, we're up to 120% of its original size. And then at the end, back to its original 100%. So when we run that, we can see as it's shrinking down, that's when the fill color, stroke color changes. And then as it's coming back up and down again, that's when the fill comes in. And by choreographing these types of things, you create a much more pleasing animation to look at. So once you've done that, we need to actually animate the circles around the outside. So again, we need to do some initial styling. So here I'm saying the opacity is 1, the fill color is that light blue. And then you'll notice here we're using transforms instead of keyframes. It's because the circles actually only need to move along one transform property. They don't need to go from here to here and then back again. They just need to go once. The reason that these two properties here, transform and opacity, are both set to 1 millisecond is because when we run the animation in reverse, so when we click it and it's already gone once, we don't want it to go again. We don't want them to like suck back in or anything like that. We just want it to go back to its original state. So there we have our circles, pretty nice looking. So now we need to position them around the heart. So in order to do that, I'm using a loop in SAS. So I'm saying for 1 through 8, target the circles using nth of type. And then we're applying a rotation to begin with. So we're taking the iteration through, multiplying that by 45 and adding 2 degrees. So it'll do that for each of the circles, and then we're translating them out. So the minus on the x value means that we're going to move them along the x coordinate, and then we're changing the scale as well. So then once we've done that and we look at it, we can see that we've actually positioned them right. It's worth noting in that last slide, actually, if you were to do translate and rotate the other way on, you would get a very different result. Just so it's worth noting that if you want to rotate something and then move it, you need to do it in that order. So there we have them positioned in the right place, but we don't want to actually show them until they're needed. So we're going to move that to be within an isActive class. So the way that this animation works is when you click the heart, I add a class in JavaScript that just says it's active, and then when you click it, I remove that class again. So by moving the circles to be within the isActive class, they're not there to begin with, but that's where they're going to be positioned when we do translate in a moment. So once we've actually done that, we need to apply a couple more styles. So opacity is set to 0. That's because as they perform the animation and move away from the heart, they're actually going to fade out at the same time. So then we need to tell it how long those animations are going to take. So transform is going to take 300 milliseconds, and opacity is going to take 500 milliseconds, and then they're both delayed by half a second. The reason for the delay is because it runs at the same time as the heart. So as the heart shrinks down, that's when we start running the circle animation. So the whole thing again comes around in that sort of choreographed fashion. This is running really slow just to show you exactly how it works. And then here it is running at actual size and speed. So those styles where I was multiplying by 45 degrees and adding 2 degrees and all of that sort of stuff, it seems quite fiddly, and I probably could have got away with not doing the additional 2 degrees, but when I was showing it without, it was like off center slightly. So when I showed the slide with them around the outside, I wanted to show them in the right place. So that's why it's got the additional 2 degrees. But actually in production at that speed and that size, you probably wouldn't notice the 2 degrees. So it's pretty cool. The bird's probably better, right? So what else have we got? This is an animation I created to sit at the top of the documentation for a front-end framework I wrote. It's called the Better Boilerplate because it was wrote while I was working at Better, and it's something that I still use today. I'm not here to talk about that though, so if you want to talk to me about the framework, then by all means, grab me afterwards, have a conversation. But how does this animation work? So the majority of it is actually made up of properties that we've talked about already. So the 2 outside screens are just using translate Y. We're just moving things up and down on the Y-axis. The 2 carousels in the middle, they're just using steps, the same as we did before, and we're just moving them along the X-axis in steps. And then the only other kind of thing that's going on here was that initial drawing of everything as it starts. So how do we draw in SVG? Well, that's made up of 2 properties. So you've got stroke-array and stroke-offset. So if we look a little bit closer at those 2 properties, you can see how drawing and animating drawing in CSS is possible. So if we start with stroke-array, the dash array is used to create gaps in the stroke. So what it'll do is if we set the dash array to 50, we've basically just created a circle, give it a stroke width and color, and then set the dash array to 50. We have a stroke of 50 pixels, then a dash of 50 pixels, and then a stroke of 50 pixels, then a gap, and that just goes all the way around and will just repeat infinitely. So if we increase that dash array to be the same size as the circumference of the circle, then we've essentially created a dash that is as big as our shape, but that means that we also have a gap or a dash the same size as the stroke as well. So this is where the offset comes in. So by setting the dash offset to 50, we then say, okay, we're going to see 50% of that gap, or sorry, 50 pixels of that gap, and then the remaining stroke. But if we increase that all the way up to be the same size as the circumference again, we actually are showing all of the gap and none of the stroke. So if we create our animations, because we've set the dash offset to be quite a large number, in our animation, if we set that to say, right, our dash offset is going to come back to 0 at the end of the animation, we've not only created something that we can reuse multiple times, but it's literally just one property. If we then apply that to our circle, so we're just setting the name and duration, and then I'm setting fill modes here. So what the fill mode does is say, when we reach the end of the animation, instead of resetting back to your original value, keep the value from the end of the animation. And then when we run that, we can see that the stroke gets drawn. So basically all we're doing is animating the offset. So we have that offset sort of the stroke hidden, and then it brings it into view as the animation runs. So when we run that choreographed with a bunch of other things, it's a really nice effect. This was something that was used quite a while ago on, I think it was Kotaku, and when they released all of the new consoles, they did these cool line drawings, and that was where the inspiration for that one came from. I was just so fascinated because I wanted to know how it worked. I wanted to really figure it out. Okay, so we've got time for maybe one more example. The next animation contains mild flashing. By that I don't mean I'm going to show you my ankle. I mean it's epileptic warning. So this is the cover for Web Designer for the animation piece that I wrote. And this is kind of where the idea for this talk came around. I was tasked with finding and recreating some animations from around the web that were either created in Canvas or JavaScript or something like that, and then trying to bring them back into the browser and doing it with just CSS. So this is the cover we came up with. It was designed by Harriet Knight. She sent me over an Illustrator file, which was just the cover, and then I exported it as an SVG and put a whole bunch of naming things around it, grouping, and then animated the whole thing. So I'd like to talk a little bit about how I did that, but more specifically about the word animation, and even more specifically than that, about the little jumping eye. And I thought this was quite cool because it's quite a playful animation. It's quite simple again. So how did we do this one? Okay, so first off, I jumped straight into my keyframes and was saying, right, so in order to jump, we need to move along the y-axis. We've done this a bunch of times. We move up the y-axis and then back down again. And then we've got 25 to 35, so the rest of that time is just going to be stood still. So then we run that, and it kind of works. It does what it says. It goes up and it comes back down, but it feels quite rigid. It could be better. We could do a lot better. We could try and breathe some life in it, trying to sprinkle some of that Pixar magic on it, make it come to life, make it feel a bit more alive. So that's when I tend to turn to storyboarding. Storyboarding allows you to quickly plan what it is your animation is going to do without jumping into software or code or anything like that. All you need is a pen and paper. You don't even need to be able to draw, as is proof. You just need to get your ideas across so that either you or whoever you're going to hand it off to do the coding can understand what it is you're trying to get. So if we just have a quick talk through this. So number one is the initial state. Number two is ducking down ready to jump, because you can't jump without first creating the energy to do so. Step three is the reaching the top of the jump. Step four is the landing. And then 5 and 6 is just using that sort of energy off, so it sort of springs up and down to come back to its original place, because it just feels a bit more natural. You don't just jump on the spot without moving first. You just can't do it. So how do we code what I've just drawn? So step one is the readying up. So readying up to bounce, we're going to scale the Y property down to 80% of its original size. So it's just going to shrink before it jumps. And then step two is the jump itself. So translate Y is up to minus 24, and then the scale Y is back to 1 again, or just bigger than 1, because actually when you reach the top of your jump, you've stretched slightly. And then you may notice here that I've got this animation going from 25 to 27 of the way through the animation. That slight gap, or the extended amount of time that it sits there, is because when it reaches the top of the jump, you want to sort of hang there for a moment before you come back down. Again, it just adds to that whole cartoon playful feel about it. And then we move on to the landing itself. So the landing, transform Y back down to 0. So we've landed again, And then we've got our scale Y to sort of scrunch it up a little. So as we land, we sort of shrink a bit. And then the last two steps are just springing back to its original size. So that was 90%, then 1. So when we run that, we can see it has a nice sort of feel about it. It's quite playful. It's just a lot better than the previous one. And then when you see that in context with the rest of the word, we've got a couple of delays running on the two I's so that they jump out of sync to each other. And then the A's do the same thing, and the O as well, which has a really nice effect to it. So what is it that all of the animations I've shown you have in common? Well, they're all created with SVG, CSS, and mostly created with SVG. But the main point is that they weren't overly complicated to come up with. It's the idea behind them, the sort of wanting to make them feel a bit more playful or anything like that. It's those little touches that seem to be the part that actually make them. It's not the complex code. It's not the hours spent drawing an image or anything like that. It's just the idea itself. So I hope I've managed to leave you feeling at least somewhat inspired to go and have a play with some SVG animation or CSS animation keyframes. There's a collection of everything I've talked about on CodePen. That URL there, which if you can't read, is srt.lt/r0sk4. It's a horrible URL, I know. But it was better than the long anyway. You can follow me on Twitter and CodePen, and thank you.